Today we'll be starting chapter 2, and this will actually be, probably none of it will be a review at all, so I'll be kind of a new material. We're going to be talking about variations and graphs. So today we're going to be talking specifically about something called direct variations. This is 2.1. So how do you write and solve an equation that represents something called a direct variation statement? So we'll go through what that means first, and then we'll apply it. As an example, before we get into math terms, we'll use an example like a real world situation. Example 1, if I put more pressure on my gas pedal when I drive, does my car go faster or slower? So this would be an example of a direct variation statement. Why? So if I increase the pressure on my gas pedal, I'll say increase pressure. What happens to the car? Hopefully, when you increase the pressure on your gas pedal, when you press it down further, you end up going faster. So you increase your speed. So whenever you have something like this happen where one thing increases and the other thing, as a result, also increases, that's called direct variation. So both quantities that you're talking about, in this case, the pressure of the gas pedal you're pressing down, and your speed is either going to go up or down, right? So either going to increase or decrease together. It is possible that you have something that's going down, but then something else would also go down. So we'll do some more examples of this as well. So it's called direct variation. They're either both going up or both going down. So some other ways like this can be referred to. One is they could say this varies directly as. So when you read this in the directions, you should know, okay, I'm doing direct variation. Another common one is varies in direct proportion to. Or the last one, if they just say the words directly proportional to. In all cases, you see the word direct. Right? The word direct is in pretty much all of them here, right? In some way or another. So that should lead you and think about it being directly. That means they're both increasing, both decreasing. One or the other. It will also lead us into the fact that we should remember this generic formula for direct variation. So anytime we have direct variation, it's always set up this way with this little formula. Y equals k times x to the n power. That's the generic form. When k cannot be equal to 0, I hope that makes some sense that k can't be 0. That would actually make the entire thing 0. And then there'd be nothing to even look at. And the power there, where n is here, that has to be greater than 0 as well. So we're not starting at 0 or doing any negative numbers. We'll be putting in like 1, 2, 3, 4, and so on. So kind of the weird thing about this one is something called the constant of variation. Right down here, constant of variation. So what is that? That is actually the letter k. So the k that's up here in this formula, is called the constant of variation. This actually changes depending on what problem you're talking about. So it's a set number, but you have to kind of find that set number, and then you can use it. But you'll know what I'm talking about when we do a couple problems. But this number constantly changes in the problem depending on what you're talking about. So when we work with the direct variation formula, the variables that would change to numbers are, like I just said, k will be one that changes to a number, and in the problem they'll tell us what n is, what the power is. They might say like the third power, or the fifth power, or whatever, and then you should be able to fill in those numbers. Let's try an example. Example 2, the volume V of a regular, this is called I think it's a icosahedron, I'm going to call it icosahedron, is directly proportional to the cube of the length of an edge. So there's a picture of one. An icosahedron has 20 faces on it. So we're going to identify the dependent and the independent variables and write the direct variation equation representing them. All right. So let's just go to the original form real quick. So I'm going to copy this down. Y equals, this is a mess. I should probably erase that. Here we go. We're going to start with y equals k times x to the n. So let's write this out here. Y equals k times x to the n. And then I'm going to rewrite this equation as I read the original statement up here again. So what was it saying? The volume V. Okay, so as I read, I'm going to replace these variables. I'm starting with V. So instead of writing y, I'm going to say it's V equals the volume V of regular blah, 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 directly proportional. So we know to use this formula anyway. We knew it because it said the word directly. To the cube of the length of an edge. Okay, so what we don't know is k. That stays there. We'll get a number for that in a little bit. And then we have x. We're going to change. Let's see. Cube of the length of an edge. So if we're talking about the length of an edge, maybe I'll just use the letter E. E. And the word cube, that's telling us our power. You have to know what cube means. That means the number 3. So this is to the 3rd power. So that would be the setup. And I didn't ever even answer the first part. What's the dependent and what's the independent? The independent would be which variable? V or E? That would be the E. This is independent. And then V is your dependent. Oh, man. Okay, so now that we have this general form, V equals K times E to the 3rd, now we're actually going to use it to find, well, what is K in this particular case? So let's read through it. A regular icosahedron with an edge length of 4 centimeters, underline this as we go, has a volume of about 140 centimeters cubed. Determine the constant of variation K. So now we're trying to find K. We don't know that one. But they give us some numbers to plug in. So let's just use our generic formula from up top. I'm going to put it down here. V equals K times E to the 3rd. And then I'm going to plug in the numbers. They should give us V and E. And then we'll have to find K. So an edge length of 4 centimeters. What does that go in for? Well, we said E stood for the edge length. So I'm going to plug this in for E. It's going to go right there. And then the volume is 140. So that's your V value. It's going to go on the left-hand side. So we have 140. You don't have to include the units, centimeters cubed. 140 equals K times, what's E? It's 4 to the 3rd power. Hey, then you're just going to take a calculator and we're going to solve for K. So you can probably do that as well. If we do 4 to the 3rd power, that's 4 times 4 times 4. So that would be, I'm going to go this way over here. We have 140 equals K times, this would be 64. And then hopefully you can figure out how to get K by itself. Since you have multiplication, we divide. So these are gone. So then you do 140 divided by 64. So it's about 2.1875. It does end there, so I'll probably just write them all out. So this K value is only for this specific example, talking about icosahedrons. So if we go down to part C, it says we're going to rewrite the variation equation, which is the one up here, using K. So we have our K value. Now we're going to go back to the generic one. It's going to be V equals, but now we know K, 2.1875. Oh, man. Times E to the 3rd. So this is the generic equation specifically for regular icosahedrons. Okay, so now we can use this anytime we're talking about the regular icosahedrons. Part D, approximate to the nearest cubic centimeter the volume, so we don't know V, of an icosahedron with an edge length of 5 centimeters. So we're going to take our new formula down here, trying to find volume. So V equals 2.1875 times edge length of 5 centimeters, that's E, times E to the 3rd. Then you just put it in the calculator. Make sure you do, oh, not E to the 3rd, sorry, 5 to the 3rd. Forgot to put the number in. 5 to the 3rd. And 5 to the third is 125. And you multiply that by 2.1875. So it's 273 as a final answer. And I'll round to 2 decimal places, 0.44. And that's in centimeters cubed. That's it. So you kind of have this process every single time. You start with the generic formula, then you can replace some letters and be a little more specific to your situation. And then you go through and you find K. K is different every time. Once you have K, now you have a more specific formula for the situation, and you can answer any question on it now that we have a K value. So I'm going to go through the steps here. This is kind of the 1, 2, 3, 4 is kind of what you do every single time of what I just talked about. So this is the algorithm for solving direct variation problems. So you're going to write the general variation formula, which is the y equals kx to the n. And you're going to use the formula to find k. So we start with this. Y equals kx to the n. Use the formula to find k. Then we're going to rewrite the formula with a value of k in it. And then use the new formula with a number for k to answer the actual question. So now we're going to combine all these steps into one question. So if you look at this example, we had, A, B, C, D, and we knew to do each one at different steps, like one step at a time. Now we're going to do it all in one question. It's going to be nice and short. So look at this example here, for example 3, which will probably be the last one we do together. I might do one on the huddle as well. Suppose B varies directly as the 6th power of G. If B equals 729 when G is 2, find B when G equals 10. So there's a lot of numbers here, and it gets really confusing. What I would do is we're just going to read a little bit at a time and stop at certain places to do the steps that it says back here, right? Write the general variation formula, find K, and so on. So as I read this, we're going to stop and write it. So the general variation formula we're going to do number 1 is always y equals k x to the n. That's just the generic one. And we know to write this because it says the word directly. It varies directly. Now we can go to step 2, use this formula to find k. Actually, no, we probably should use the letters up here first, and then we'll get to step 2. So I'm just going to read the first sentence. I'm going to stop here, actually. Let's put a little stopping block here. Suppose B varies directly as the 6th power of G. So right there, they gave us letters to use, B, G, and they gave us our power, 6. We don't know K, but we can just read it, and we change letters. B is Y, so we go B equals KX. X is actually going to be G, and the power is 6. So this will be our generic one. So since we stopped there, we're good there. Now we're going to go to the next step. Use the formula to find K. That's going to be the next part they tell you in the sentence. So we stopped here. We can keep going. If B is 729, when G equals 2, stop again. They gave us enough information to find K. Plug in B, 729 equals K we don't know, but we know G in this case is, man, even I wrote G. It's 2. 2 to the 6th. And then we do the same thing we did before. Solve that for X. So try that and see if we can get it. 2 to the 6th power is 2 times 2 times 2 times 2, 6 times. So we have 729 equals K times, I think we get 64 in this case, 2 to the 6th. Same thing, we did the power, now we divide. So a different K value than last time. Do 729 divided by 64. I'll round to probably just 1 decimal in this case. It comes out to be 11.39, so I'm going to round it to 11.4. So that is step 2. Use the formula to find K. Write the formula with the value of K in it. Now we're on this step. So I'm going to take this K value. I'm going to go back to this step here and combine them essentially. So we put these two together. It's going to be B equals 11.4 times G to the 6th. I'm just plugging in k to this formula here. That is step 3. Now we can finally use the formula to answer the question. And you notice we stopped twice already. Now we just got to finish the rest of the sentence. Find b, so down here with our new equation, find b when g is 10. So let's write it underneath there. So b equals 11.4 and g is 10. Oh boy, that's times 10 to the 6th power. This is going to be a big number. So 11 you do 10 to the 6th first, and then times by 11.4. So 10 to the 6th is 1 million. So you have 11.4 times 1 million. That's 6 zeros. And then you multiply that by 11.4. So it's just 11.4 million, or 11,400,000. And then finally, we answer the question. Make sure you go through all these 4 steps. Otherwise, you're going to be really confused reading through this and seeing, well, there's like multiple values for G. How do you do that? You have to go one step at a time. Read through a sentence, stop, go a little bit further, know when to stop, and then finish it up. So there's a lot of work involved in just this 1 or 2 sentences. So there is Team Huddle. You guys are going to finish. I think I'm only going to go through like one problem. I wanted to go over some of these different kind of real world examples and see if they kind of make sense. Since we only did one example about pressing on the gas pedal and seeing if your speed increases or decreases. So let's go over this one here. State whether the following situations illustrate a direct variation scenario. We're just going to write yes or no. So we're looking to see if we increase one thing, does the other thing increase? Or if one goes down, does the other thing also go down? That's our 2 options. The more you run, the less you weigh. So if you run more, you might lose some weight, so your weight will go down. So is that direct variation? No, it's not. All right. The hungrier you are, the more you eat. So if you're more hungry, it's increased hunger. The more you eat. All right. So that would both be going up. You're really hungry. You're going to eat more. So that would be direct. So yes. The less sleep you get, so if you decrease your sleep, the more tired you are the next day. Increased tiredness. I just like to draw the arrows, so hopefully you can understand if we're going to get one of these double increase or double decrease. You sleep less, you're more tired the next day. That's a no. And lastly, as you buy more video games, if you increase video game buying, the more you pay in sales tax. You're going to increase how much you pay in sales tax. That would be direct because they're both going up. So yes. Okay, so the rest of it you should finish. The huddle and the mastery. There's only a couple problems left. Hopefully that wasn't too bad. And hopefully you understand this as well. Being able to create your own or understand when you have direct variation or not. And so that will do it all. That'll be it for 2.1.